Welcome to The Explainer. Today, we're going to crack open a recipe that's been cooking for billions of years. It's the Earth's secret formula for how it builds itself layer by incredible layer. Okay, so look at these two things. On the surface, they seem worlds apart, right? On one side, you've got this breathtaking geological masterpiece, and on the other, a pretty simple science model you could make in a classroom. But what if I told you they're basically made from the same recipe? Seriously, the very same fundamental processes that created these little layers in a cup are the exact same ones that carved out one of the greatest natural wonders on our planet. Let's break down how it works. So let's think about this like we're making a giant, and I mean giant, geological sandwich. It's a recipe that takes, millions and millions of years to get just right. All right, so every good sandwich, every great recipe starts with the ingredients, right? For our Earth sandwich, the absolute star of the show is something called sediment. So where do these ingredients come from? Well, they're made by two super powerful forces working together. First, you've got weathering. Think of it like a cosmic hammer, just smashing big mountains and rocks into little, tiny pieces. Then you've got erosion, which is kind of like the delivery service, wind, water, ice, that picks up all those broken bits and carries them away. And these tiny little particles, this sediment, that's the whole shebang. It's the rock, the sand, the silt, even the leftover bits of ancient plants and animals. This is the stuff we're building our entire sandwich with. Okay, so we've got our ingredients. Now it's time to see how the master chef, Earth itself, starts layering it all up over just unbelievable amounts of time. This whole layering thing, it's called deposition. And it's not just a random pile. Think about it. Each layer is like a little snapshot in time, a perfect record of what was happening on the planet right then and there. And what's so cool is how different conditions create totally different layers. So picture this. You've got a really fast, powerful river. It's strong enough to carry bigger stuff, like sand. When that water finally slows down, boom, all that sand drops out and makes a thick, kind of coarse layer. Okay, now jump forward, say a few thousand years. Maybe there's a huge, crazy flood that just tears through, carrying everything with it. Mud, rocks, even boulders. It dumps all that junk right on top of our nice sandy layer. And that creates a totally different kind of layer, a real chunky mess we call a conglomerate. And then maybe the climate changes again. The river gets really slow and lazy. Now it can only carry the tiniest, finest particles of silt. And over thousands of years, that fine dust just gently settles out, creating this delicate new layer. See? Each layer tells a different story. It's a history book written in stone. Okay, so we've got our layers stocked up, but right now it's just, well, a loose, soggy pile of stuff. It's not rock yet. To turn it into actual rock, it has to get cooked in the Earth's natural pressure cooker. And the first step in that cooking process is called compaction. Just imagine, as more and more layers pile on top, the weight becomes absolutely incredible. We're talking miles of rock and mud building up over millions of years. And that pressure, it's almost impossible to really wrap your head around. It literally squeezes those layers together, forcing out every last drop of water and every little bubble of air. It just crushes those sediment particles closer and closer together. Our little classroom model gives you a tiny idea of what's happening. Those heavy objects on top are like the millions of tons of rock pushing down, squishing those bottom layers into something much more dense. But just squeezing isn't enough to make it rock. There's one final, super important step: cementation. You see, as all that water gets squeezed out, it leaves behind dissolved minerals. And these minerals then crystallize in all the little gaps, acting like a natural superglue that binds everything together into one solid piece of rock. Okay, but here's where the recipe gets really interesting. What do you think happens when ancient life, plants, animals, gets trapped in those layers while all this cooking and squeezing is going on? And I'm not talking about, finding one cool dinosaur bone. Imagine entire forests, whole swamps just getting buried. Or think about oceans, where for millions of years, trillions of tiny little organisms died, and their bodies just rained down onto the seafloor. Well, when you take all that organic stuff and you bury it, and then you subject it to that same incredible heat and pressure we just talked about, it gets cooked, and it transforms into what we now call fossil fuels. The recipe itself is actually pretty simple. You need tons of organic life. You need to bury it deep. And then you need a whole lot of pressure, heat, and time. Lots of time. And here's a fun fact for you. Most of the oil we use today doesn't actually come from dinosaurs. It comes from zillions of tiny little sea creatures, plankton, that died hundreds of millions of years ago. All right, so our geological sandwich is baked. It's got layers of history, it's got pockets of this ancient, stored energy. But here's the magic. Geologists can actually read this recipe backwards. They can look at the rock and figure out the story of our planet's past. So when you see a cliff face like this one, you're not just looking at pretty stripes. You're looking at a library. Every single one of those layers is a chapter, telling you a story about an ancient river that flowed here, or a deep ocean that disappeared, or a huge desert that existed right where you're standing. And you can start to piece together the planet's history just by asking some basic questions. You know, the bottom layer is the oldest, right? It had to be put down first. And the type of rock in each layer tells you what the environment was like back then. It's like being a detective for the planet. It really makes you think, doesn't it? The ground under our feet isn't just dirt. It's a library of time, an incredible story written in stone, just waiting for someone to come along and read it. So it makes you wonder, what stories are hidden right underneath you right now?